Oh, my name is Tongtao Zhang, and I just advised Ravi to do the project. And the project is about taking a picture on a certain location, and then you know where you are, and then there's some navigation instruction from the iPhone or from the Android phone. So let Ravi introduce the details.
How you doing? I'm Ravi Netravali, and I worked on this. Our project is called Columbia Navigator. It's an Android-based application, which is more of an add-on to current navigation systems today, and it provides functionality of using visual search for navigation as well as providing an accurate GPS reading via a digital FIR filter. And so what it does is if you're a user in a skyscraper or on walking on the streets of New York and you get a pamphlet or you take a picture from way up high of a building, 2 or 3 avenues away, you're unable to get pure directions to it because you don't have a straight line of sight path from you to it from on the ground. And so what you're able to do is you're able to take a picture via our service, upload that picture to a database of pictures we have here on the server, and get a best matched image. And each image in the database has GPS coordinates configured with it, along with metadata describing what exactly the image is of. And and when you get the best matched image, you get both of those, the GPS coordinates and the metadata with it. Our system then also provides your current location to the best reading we have via a digital FIR filter, taking 9 running samples of your GPS location from your phone and keeping a weighted average such that you have the best possible GPS reading, especially because GPS is suspect in cities due to lack of line of sight to satellites and a lot of multipath loss. And then once you have these readings, you have two sets of GPS coordinates. You have your reading from the FIR filter and the GPS coordinates from the best matched image. And you're able then to have, now using existing navigation systems, you're able to get a pure navigation from where you are to where that image is, which could be very close if you're able to directly take a picture, or it could be 100, 200 blocks away if you're simply taking a picture of an image or a pamphlet. And from that, the big robustness issue comes where in terms of the matching algorithm and how good of a match it is, and the wide collection of images you have in your database. Because if your database isn't very well populated, if you take a picture of an image on a foggy day, it won't match properly to a clear shot image of that same landmark. And so those are things that we're addressing right now, and that's one of the reasons we chose to use our own matching algorithm, just because there's certain things which we need to take more seriously than other existing matching algorithms. Okay, so this is the application. It's called Navigator. And this is the home screen where you're able to, because we chose to use Android, you're able to use the functionality of the phone, which includes the built-in camera and all the navigation system that already comes pre-made, which you wouldn't have this functionality if you used Apple or iOS. And so this is the home screen, and what it does, it links you to the camera, and can I just take a picture? And so if you take a, can you hold this one? Okay, I'll hold it. So if you were outside and this is the, oh sorry. So
There we go.
okay, so now if you start this system of the camera, let's say you take a picture of this image outside, it's able to capture the image, and now if you click select OK, it will upload this image to the server that we have running here, and it's connecting to the server. And then it'll come back with the best match image along with the GPS coordinates and description of the image. This is the best match image it finds, and so now you're able to get directions. The coordinate A is from a digital FIR filter, which we have just here. This is the digital FIR filter. It's connected to the phone via Bluetooth, and it keeps a running sample of it. So this is the digital FIR filter, and it's connected to the phone via Bluetooth. And what it does is it's able to keep a running sample of 9 GPS readings directly from your phone GPS. And this eliminates having several outliers and such, simply because it compares each new addition of GPS coordinate to the weighted average, and if it's an outlier, it eliminates and gives you the most recent accepted reading. And so then this reading comes as the destination reading, or as the starting location, and the destination location GPS coordinate is from the best matched image. And then from this, now you're able to you have directions from where you are to where this image is, And if you click on the image selected, you'll then start the navigation system as provided by the phone. And then just to go back, and you can always just restart, because it's Android and it operates on a stack, you can start over simply by just clicking back as opposed to having to restart the application.